Hey there, and thanks for joining in another channel review. Some weeks ago, I had the chance to review the very compact Venlab VM-600M multimeter, and I recently received for review that model big brother, the VM-600M. It is bigger and more complete multimeter. It still is manual, but with a lot of options in it. And I've passed these last couple days testing it. I have already a very accurate idea about this multimeter, but bear with me while I test almost every function of this device and create your own opinion about it. As usual, the normal disclaimer to let you know that Venlab sent this multimeter for review free of charge, and also I didn't receive from Venlab any payment for doing this review. Anyway, thanks to Venlab for their collaboration with the channel, and for all of you that use the channel affiliate links on the description or the channel affiliate access links here in the screen before paying your purchase on AliExpress and Amazon. Your help is really appreciated. So without further ado, let's see what this can do. We have here the box where it is delivered. It's the normal box. It has only some informations. So inside, let me start by showing that we have a pair of lids. They seem okay. We have also two fuses for replacement. We have here a set of batteries, and I like devices that include batteries when you are opening it, so you don't have to go find batteries to start working with them. And you have the 600M, the VM-600M. Let me take the box out of the way. Also a user manual, not a colored one, but it seems very organized. Infographics, yeah. I believe this has several languages. I remember that the last one with VM-200M. We have here multimeter user manual, and something in English, but we didn't have the English on the user manual, and it seems to be the same situation. You have Dutch, Français, Italiano, Espanol, and 3 years warranty on the 54. That's in English, but yeah, I don't see here anyway English. Okay, that's a curious fact. So English user manual, we don't have it. Let's open this. Okay, this plastic tends to be a bit hard to open. Never mind. Okay, let's wrap it. And we have here the big one. I already tested the VM-200M, and now I have this one. I should say that the first impression, it's pretty good. We have this plastic but almost rubber protection all around it. It is all around it, and yeah, the rotated knob, it's pretty good, easy to rotate, and yeah, only two buttons, function holds and the light. We have NCV and the NCV sensor. We have a light, and yeah, a stand. Yeah, it seems to have a magnet here. Yes, it is. We have a magnet, and also you have well, this is for hanging on a screw on a wall. You have two holders for lids right here. Yeah, in terms of first impressions, not bad at all. Not bad. Let's see in terms of accuracy how it is. I will have to open this to put the batteries in. So that's it. We have 4 batteries. And okay, we're ready to test. Okay, only missing to see how the test leads are. Let me take it out. Okay, so they seem pretty nice. Yeah, we have this cover, this tip to cover, and I don't see anything out. So this is really a protection cover. It's not one of those covers that we have that allow us to have the tip in the end. It's silicone, I think. Yeah, this is silicone. It's pretty smooth, but this is just a protection. Normally operates like this. Okay, and in terms of the cable is very flexible. It's not that plastic that it's not able to bend. Yeah, it's very flexible. I will not say this is silicone, but if it's not, it's a plastic, very flexible. Okay, in terms of I call it probes, but it's not probes in terms of leads, and they are Cat 3, as you can see. So let's start testing this. Okay, well, the first thing is take the plastic out. Let's do it. Oh yeah, nice. Okay, so to show you the operation of this device, as normal, you have the milliamps socket here, the fused 20 amps socket, the common, and this is for voltage, resistance and frequency. In terms of the operation of the device, you have the multifunction here and the hold function. You have the key for turning the backlight and also the light of the device. Let me show you. We can have a backlight on. I prefer to record without the backlight because it's clear for seeing the letters. But if you press a bit in this button, you will power a very bright light to help you. This is quite common today in the multimeters. And if you press again in the button, you will disable. You have to enable again the backlight. In here on the top, you have infrared sensor. For detecting infrared, you have to take this to the infrared sensor option, and you will be able to see if a remote it's working or not. In here, you have a NPM or PNP transistor testing system, socket. For that, you will also take this to HFE for testing. And again, we have here on the top NCV, also available when you move to NCV here on the knob, and that will be light up when it detects current or voltage in a live wire. It will use this sensor for that operation. In terms of what you have in here, you have diode detection or measurement, you have continuity, and you have from 6 ohms up to 60 mega ohm in terms of resistance. You have NCV and infrared detection. In this side, you have the DC voltage from 6 millivolts up to 1000 volts. You have also AC voltage detection from 6 volts range, of course, up to 700. And in terms of alternate current, it goes from 20 to 60 megaamps. We have also, in terms of milliamps, continuous milliamps, from 60 microamps up to 20. And I already show you the HFE or beta, the hertz for frequency measurement, and we have here this small area for capacitance. So you have basically everything you need on this multimeter. Let's start testing. I have my setup already in place for testing the DC voltage. I will start by using my DC voltage calibrator. It's 0.02 grade. I have the Venlab VM-600M here and my Siglent SDM3045X here to check the voltage. That is a very accurate multimeter. So let's start. I will not comment a lot the values to speed this up. So starting with 1 volt, 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, 9 volts, and we are back to 0. So as you can see, it's pretty much on the spot on. So we will now enter the millivolt range. For that I will diminish here the range, and let's start with 100 millivolts. Okay, spot on. 200, 300, 400, 500, 600, 700, and 800, 900 millivolts, and we are back to 0. Again, 1 digit off, the less significant one, so I take as a win this one also. Let's pass to the maximum of 99.999 volts, millivolts, sorry. So let's start, and I think that I will have to move this again. So 10 millivolts, 20 millivolts. Yeah, it's bouncing a bit, but it's 20. Yeah. 30 millivolts, 40 millivolts, 50 millivolts, 60 millivolts, 70, 80, 90, and again we are back to 0. Once again, it's a little bit off in one less significant digit. I don't take this at all. I think it's quite accurate for this device. Let's lower the range. Okay, so right now we have 1 millivolt. Still get it. 2 millivolts. 3 millivolts. Oh, spot on, almost. 4, yeah, it's bouncing, but 4 millivolts, yeah, 5 millivolts, 6 millivolts, 7 millivolts, and as you can see, the Siglent is spot on. 8 millivolts, 9 millivolts, and again 0. Once again, 1 digit off in some of them, so pretty accurate this one. Let's move on. Nowadays I can test the equipment I review with my DC voltage calibrator, but since the beginning I test all the devices with this millivolt voltage reference board that I created, and then I will test it also with this, so we have a base of comparison. But before moving on, let's hear about the channel sponsor, PCBWay. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, a 3D printing service, and much more. Now that we all know how you can create also a board like this, let's start testing, and the first value will be 10 millivolts. Okay, we have 10.6 millivolts in the Venlab and 10.65 on the Siglent. Pretty awesome. Let's pass to 25. 25.2. Wait, let's grab this. 25.2 in the Venlab, 25.25 in the Siglent. Moving on to 50 millivolts. Still spot on. Exactly the same values. This is very good. Okay, 100 millivolts, and this one it is a little below, some digits off. We have 99.9 here, 100.03 in the Siglent. Okay, moving on. So in 250 millivolts we have 249.8 on Venlab and 250.0 quad and 250.0405 in Siglent. Let's move on to 500 millivolts. On 500 millivolts we have 501.6 in the Venlab and 502.0809 on Siglent. Okay, let's move to 1 volt, and I think that I have to change here the range. Yeah, exactly. We have 0.989 volts in the Venlab and 0.990 on Siglent. So 1 digit off, it's good. Let's move on to 2.5 volts. We have 2.49 in Venlab, 2.4970 in Siglent, almost spot on also. And this last one is the weird one that I never get the same voltage in here. So 4.975, 4.977 on the Siglent. Pretty awesome, very accurate really. So I'm pretty satisfied with this test. Let's move on. Now I will do a current test with milliamps. Let's start with 1 milliamp. Spot on. 2, 3, okay, 4, 5. It's drifting a bit in the less significant digit. Let's take it to 10. Okay, it's increasing the drift. Yeah, right now it's 7 digits different. 15 volts. Okay, it's increasing. So right now I have 10 digits, 10, 11 digits difference. Let's take it to 20 millivolts. In 20 millivolts we have 14 digits difference, and the maximum is 24 milliamps. I said millivolts before, sorry, milliamps. So in 24 we have 23.84 milliamps. Yeah, that's it. My Siglent is damaged in terms of milliamps measurement, but I brought my Unity 61E for checking. So let's see what we had. We had previously 23.85 on the Venlab, and my Unity says 24.03. So we have a drift here, or about 15 digits. Yeah, not perfect, but yeah, it will not damage yet the good impression that this device is leaving. Okay, let's move on. Okay, so now I will show you the NCV function. For that you just take the knob to NCV as it showed. You will have on the screen this NCV indicator, and you have this test sensor that you will use for testing. I will use this sensor to get near this live wire. Yeah, and as you can see, it detects from, yeah, like 4 centimeters, 1 inch. It is able to detect, and if you are really near, it will show you this red light. Yeah. So another function that you can also use is the input, like this, and this will be able to test also the voltage. For that, you just, for example, insert here. It will not tell you nothing, and if you put on the on the opening that has power, it will show you that is live. Again, nothing here, and also nothing here. This is the one wire live function of the device, but it's not documented anywhere. You just have to use it like this. Yeah, this is the earth connector, and you have also the common. Okay, works pretty well. Okay, let's now see how we can measure AC voltage. Whoops. I will take this to 600 volts here in the meter. We have the symbol with the V and this wave for that. Everything seems to be okay, so I will start by inserting the common in the sockets, and after, yeah. So in terms of voltage, it detects 234 point something, 35, 34. So the normal here in Portugal is 33 to 35. Oscillates a bit, not much, but yeah, we just had a drop. And let me take it out and try again. Yeah, 34. It's quite steady here, the voltage, so it's normal around 34, in the middle of 230 and 40. Okay, it seems okay. Let's move on. Okay, let's now test continuity. I have here both leads. Let's start to see if this is fast detecting continuity. Not so fast. It's faster than usual to get in the screen, but the contact doesn't seem to be very fast. Okay, now we are talking. Okay, that's good enough anyway. Here in the end, it seems to have better contact. Yeah, now we are talking. Okay, and the screen updates also very fast. Yeah. Okay. I'm good with this. So now I will test the resistance. For that I will use this reference board. We have the values written in here. So let's start with 10 ohms. Oops, I forgot to change this. Like this. Let's start with 10 ohms. So we have 10.1, almost spot on. Next we have 100.03, I believe. Yeah, 03. Almost spot on also. 100. Okay, it's within the error margins. I will have to increase this again. So now we have 100k 0.0003. Yeah, spot on also. Let's move on. We have now, okay, moving on again, 9.995k. Okay, also good. And finally we have 100k, I believe, with something. I will put on the screen the correct values. I think that, yeah, once again, moving on, new range. So 199.9, yeah, almost there. So in terms of resistance, that's it. Let me just see what this one it is. I think it's 600 and something K. I use a lot in my millivolt board. I know, 2K, 1.9. Okay, that's it. So right now it's capacitance time. Let's start with 102 picofarads. I don't know if this will be able to measure that. It says 0.72 nanofarads. Yeah, not very accurate, but I don't know if it is in range. So the next one is 1.02 nanofarads. Okay, spot on. The next one is 10.4. Let's see what we have. 10.37. This has 4% plus 5 digits error margin, so it's spot on within the error margin. The next one is 98.7 nanofarads. Let's see. 98.58, also good. And the next one it's 929 nanofarads. Let's move on. Yeah, 99.28. No, this is a little bit far, but I'm starting to doubt of this value because I tested this capacitor in several multimeters, and all of them give me a value near the one I'm getting here, that is 895. So I believe the correct value is 895.96 and not this 929. To take this to check this out, I will order a new board, a new reference board, so we can have this for sure. But yeah. And this last one, it's 10 microfarads. Let me just... Okay. Here it is, 10.5. Just to check again, let's take this and let's try with the Siglant to see what I have here in capacitance. Okay, so let's try this one on the Siglant, and it gives 0.924 microfarads, so this is 923 nanofarads. Okay, so the value it's okay. It's a little difference for the Siglant, but it's reading the correct value almost. Yeah, so it is also a drift on this one. Even so, the rest of the values are quite accurate. Let's do just a quick check on diodes. I have here two. I believe this is 2 volts and this 1.7 or 8, something like that. Let's try to check this one first. Okay, like this, and yeah, 1.94. Yeah, and the second one 1.79.4, so it's 1.8 in terms of volts, but I don't see the lights powering on, so yeah. Okay, so right now I'm going to do a HFA or beta testing. For that I have 2 multimeters and a component tester to see what values I got. I'm gonna start by this one. I think this is a 1N222. So it should be a NPN. Let me just start by putting here, and oops, sorry, I didn't have this to the correct. So this one has a gain of 311 on this oscilloscope. If we come, on this multimeter, the Venlab, if you come to this multimeter, it says the gain is 315. Yeah, pretty near. And let me take this and do a test. And in this component tester, it says the gain is 305. I think those two are more accurate. Okay, so this one it's done. I think right now that I have here 1015. Let me take it. I don't know if it's, I don't remember if it's NPN or PNP. Not working, so let's try as PNP. Okay, now we have it working. So this one, it's the 1015, and we have a gain of 393. Two? Yeah, 19-ish. 90. Yeah, 390. Let's take it like that. It's still adjusting. Yeah, okay. Yeah, it's stabilized 383. This is a PNP, so I will have to change it like this. Let's try. And in this one, it's stabilized immediately at 376. A big difference. Let me see what we have in here. Okay, and again 361, it says it's PNP. Okay, very nice. Again, let's try another one, and this one it's NPM. Okay, it has a gain of 365. Let me change here. It says this one, it has a gain of 359, 355, 50, yeah. It's oscillating a bit, but 357, and let's say what the component tester says. So in the component tester, we have a gain of 353. Okay. Nice. It seems in line more or less with the values I've got from the other devices, so I take it as good. Right now I will test the frequency. The user manual says that this device has a frequency limit of 10 megahertz. I right now have 1 megahertz, but let's start with 1 hertz to see what we can detect in here. I have a VPP of 10 volts and 1 megahertz. It took a while, but yeah, it got here. 100 hertz, 99.99. Okay, acceptable. Let's move this to 1 kilohertz, 999.9 hertz. So 1 kilohertz, 100 kilohertz. Okay, it's always 1 digit below, but okay, that's totally acceptable. Let's move on to we are in 10 kilohertz, 1 megahertz. Okay, let's put this in 1 megahertz. So in 1 megahertz we have 99.9. Again, always 1 digit below, but no problem there. It might be from the cables or anything external. Okay, so let's move on megahertz by megahertz until we have the 10 megahertz. 3, 4 megahertz, 5, 6, 7, 8, 9, 10. So up to 10 megahertz it's I will call this almost spot on. It's not really on the target, but it's 1 digit off. And okay, let's continue to see what else we can do with this. 13 megahertz. Curiously enough, right now it's spot on. 14, 15, and don't forget that the limit for this is 10 megahertz by the manual. Let's see. Let me check again. Yeah, it's 10 megahertz with 1.5% plus 5 digits difference. So 16 megahertz, it's spot on. Let's move on. 20 megahertz. Awesome. Let's take this to 30 megahertz. 30 megahertz. Very nice. Okay. 35. 40 megahertz, still spot on. What is the limit for this? 45. 50 megahertz, it's 1 digit up right now. 55, still good. 60 megahertz, and right now my function generator changed the VPP to 5 volts VPP, and that altered the capacity of addressing the results here. Let's go back and try to go up slowly. So even so, 41 megahertz. Let me just do this in lower steps. 45, 40, and 45 seems to be the maximum with a VPP of 5 volts. Even so, this is rated for 10 megahertz, and it's being able to identify up to 45 megahertz with a VPP of 5 volts. And if you use the VPP of 10 volts, you will be able to go up to 60 megahertz. So I'm quite glad with this. Let's go back to 10 megahertz, and I will try now something different. I will increase the VPP again to 10. And what I want to see now, it's the duty cycle. So let's put this in a pulse duty ratio signal. Right now it's identifying the signal with 50%, and I'm starting to be very happy with this, because right now I have 12%. Let's increase this. 12% is the minimum. Okay, I'm increasing, and yeah, almost at 50%. 50%, spot on. And let me take this up to the maximum, should be 80 something, 88. Yeah, it will not identify near the extremes to the most current position, but even so, it's pretty good. Okay, for me this is it's a winner for sure. 50%, totally okay with this. Okay, moving on. Right now I will show you how to identify if a remote control is working properly or not. It has here a remote control sensor. I will put this on the vertical so you can see it better. And if you press your remote control, it will show you a light blinking when the packets are received. Not all the remotes function the same way with this, but yeah, for at least for the 2 remotes that I tested. This is from my TV box and from my TV, LG remote control. So yeah, it seems to work pretty fine. This will not identify the signals, but at least it will allow you to see if the remote is working, it's transmitting or not. It's just a debugging tool, pretty basic one. All tests made, let's wrap this up. I'm going to start with the design and overall quality. That is really good. This rubber-like case is good and completely encloses the multimeter, giving it good protection. It will not give an anti-slip protection, but in terms of falls or damage, protects the multimeter. While the multimeter itself is only 6,000 counts, not much in my opinion for a multimeter like this, where I would like to see 20,000 counts, but even so, it packs a lot of features in it. You even have a IR remote tester. In terms of precision, and in my opinion, for the tests I made, it is reasonable. Most of the tests were precise and within the tolerance reference in the user manual, so I didn't find any major problems in there. So let's talk about the price. At 20 euros or $22, yeah, more or less, it is in line with the other multimeters with identical features. Even like if I already mentioned, seem packed with a little more functions like the ER tester. So it is an average price for this device. This multimeter is really nice equipment, very accurate. So if you want a multimeter accurate and packed with features for a reasonable price, you can buy this unit by using the affiliate link in the description or one of the access links here in the screen. Same price for you, but a big help for the channel. I really appreciate your help. And if you learn anything at all today with this review, please spread the love and slap that like button and hit that bell and activate all notifications if you want to be one of the first to be notified whenever I upload a new video. That's it for today. I really appreciate your company and I hope to see you in my next video. Thank you for watching.